any solid figure contains length, width, and height. Okay, so in your surrounding there are different solid figures. Okay, you can take in your home, you may have a box. Okay, a box is a solid figure which contains 3 dimensions. You may have a ball which is a 3 dimension. Okay, there are a lot of 3-dimensional solid figures. Okay, out of which we will be focusing around 5 solid figures. Okay, the first solid figure type that we will discuss is about a prism. Okay, this solid figure is called a prism. Okay, we call this a prism. And the second solid figure that you can see here is a sphere. We call it a sphere. And the third solid figure that we will have a discussion on this unit is about a cylinder. And the fourth one is a cone. And lastly, we will see a pyramid. Okay, so today we begin our discussion on the first solid figure, which is about a prism. Okay, so in all these cases, we will have a discussion on the properties of a solid figure, and we will also see the measurements, like calculating the surface area and the volume of the different solid figures. Okay? So, as you can see here, we do have different solid figures here. All these solid figures are a solid figure, and their name is prism. Okay? So, there are different types of prism. We can classify prism depending on the nature of its base. Okay, so this is called a triangular prism because the base is triangular, and this is called rectangular prism. And the third solid figure that you can see here is called hexagonal prism. We call it hexagonal prism because of the number of sides on the bases. Okay, if a certain polygon has 6 sides, that polygon is called hexagon. So as you can see here, there are 6 sides on each of the bases. Okay, so you can further classify this prism depending on the bases. Okay, so in all these cases, each of these solid figures contains a lateral face, which is a parallelogram, particularly rectangular faces. Okay, so you can also have a pentagonal prism, heptagonal, octagonal, and so on. Okay, so these are some of the types of prism. Okay, now we will have some terminologies regarding a prism. Okay, these terminologies are the same for any kinds of prism. For example, here we have a rectangular prism, meaning that a prism having a base rectangular shape. Okay, so in all the prism cases, we do have different terminologies like bases. Okay, in this solid figure, we do have 2 bases, the upper base and the lower base. Okay, here the upper base is A, B, you can read in this way or in any order. A, B, C, D is an upper base, okay, and E, F, G, H is a lower base. Okay, so always whenever you think of a prism, any kind of prism contains 2 bases, an upper base and a lower base. The other thing is the intersection of the lateral faces is called lateral edge. Okay, what are lateral faces? Okay, this face, the front face, AEHD is a lateral face. The other lateral face is HDCG. Okay, this part is also another lateral face. And we have at the back, which is BCGF. Okay, the third lateral face. And the fourth lateral face is AEFB. Okay, so a rectangular prism contains 4 lateral faces. As I have said before, the intersection of any 2 lateral faces is called lateral edge. Okay, in this figure, our lateral edges are DH. Okay, this DH is the intersection of the front face and this face. Okay, we do have DH, CG, BF, AE. Okay, we do have 4 lateral edges. At the same time, we have 4 lateral faces. The other thing is base edge. Base edge is a line segment which is the intersection of the lateral face and the base. Okay, for example, here this part, the lower rectangle is a base. You can see this is a lateral face. The intersection of this rectangular face and the base is this EH. Okay, so we do have 4 on the base part. We do have 4 base edge: EH, HG, FG. So here, in this prism, we do have different terminologies, okay? You need to be familiar with different terminologies in different solid figures. Okay, here, as you can see here, we have a solid figure, which is called a rectangular prism. In this rectangular prism, we do have upper base, which is the upper part of the rectangular region. Okay, so A, B, C, D is an upper base. Okay, A, B, C, D is upper base. Okay, upper base. And we do have another base, which is E, F, G, H. Okay, E, F, G, H is a lower base. Okay, so it's not only for rectangular prism. Any prism contains 2 bases, the upper base and the lower base. In this case, our bases are rectangular region, so we do have 2 bases. The other thing is the front face, the back face, and the side faces are called lateral faces. Okay, so our lateral faces are 4. These 2 are the bases. Okay, these 2 are the bases. The lateral faces are here. The lateral faces are 4. We do have 4 lateral faces. These lateral faces are the front part, A, E, H, D. Okay, one of the lateral faces, A, E, H, D. Okay, the front part, A, E, H, D is one lateral face, and the side part, we do have D, H, G, C, another lateral face, D, H, G, C. The third lateral face in this figure is the back part, which is B, C, G, F. Okay, B, C, G, F. This is the third lateral face. And the fourth one is A, E, F, B. A, E, F, B. Okay, we do have 4 lateral faces in this solid figure. Okay, so far we have seen 2 terminologies, the bases and the lateral faces. The other one is the intersection of a lateral face and the base is called edge. Okay, edge is EDGE. Okay, it's not AGE. Okay, so edges are a line segment which is the intersection of the lateral faces. So this DH, CG, BF, and AE are lateral edges. Okay, so here here our lateral edges are 4. These lateral edges are AE. Okay, AE is one of the lateral edge. The second lateral edge is DH. The third one is CG. And the fourth one is BF. Okay, here we do have four lateral edges. Okay, I repeat it. Lateral edge is the intersection of two lateral faces. Okay, we do have also base edges. Base edges are a line segment formed by the lateral face and the basis itself. For example, this segment is the intersection of this face, DHGC, and the base EFGH. Okay, so we do have around eight base edges. Okay, so this HG, EH, EF, the fourth one here, FG. These are the base edge which are found on the bases. We do have another base edge on the upper part, which is AB, BC, CD, and AD. Okay, so totally we do have around 8 base edges. Okay, the last terminology that you need to know here is the vertex. Okay, vertices is the plural form of a vertex. Okay, in this solid figure, we have 8 vertices. Okay, so A, B, C, D. Okay, these sharp corners are the vertices of this prism. Okay, so you can see all the vertices. So totally, if you are asked to mention the number of vertices for a rectangular prism, you need to say 8. Okay, so these are the terminologies that you need to know in the discussion of a solid figure, so that whenever we discuss in the future, whenever we discuss the properties of a solid figure, you can sense which parts of the solid figure we are talking about. Okay? Okay, next, let's see the properties of a prism. Okay, so as we have seen before, we said that, okay, we have seen the terminologies associated with prism. So now let's see the properties of a prism. Okay, this property works for all types of prism. So whenever we think of a prism, one of the properties of a prism is the bases are parallel and congruent. Okay, the bases are parallel and congruent. Okay, this is one of the property of a prism. Okay, the second property of a prism is the lateral edges are parallel and congruent. The lateral edges are parallel and congruent. Okay, so this is the other properties. And the third one is each lateral faces are parallelogram and rectangles. Okay, each lateral faces are parallelogram and rectangle. rectangles. Okay, these are some of the properties of a prism. Okay, so knowing the properties is very essential to prove and drive formulas in the discussion of measurements. Okay, so you need to remember all the properties of a prism. Just I'm trying here to merge the different properties as a single property. So you need to keep in mind this all these properties. Okay. So now I will show you how you can calculate the surface area and the volume of a prism. Okay, whenever we say a surface area, we need to differentiate two things. Okay, so there are two things. One of the area type is the lateral surface area, which is usually denoted by AL. Okay, the second area is the total surface area. This symbol is used to represent the total surface area of a prism. Usually not only for a prism, for different solid figures, we will use this notation to say lateral surface area and total surface area. Okay, so now by definition, the lateral surface area is the area of each faces. Okay, that means you need to calculate the area of the front part, the side part, the back rectangle, and the other side part. Okay, now let's see what the formula looks like. Okay, so the lateral surface area, AL, is equals to the area of the front part, AEHD. Okay, area of AEHD plus the area of the side rectangle, DHGC. Okay, DHGC plus the area of the back part of the faces, which is BCGF. Okay, BCGF. And the fourth one is ABFE. Okay, area of ABFE. Okay, the other thing, you all know that the area of a rectangle is a product of lengths and widths, right? ABFE. Yeah, thank you. This is E here. ABFE. ABFE. Good. So now, next we apply the property of a prism. We said that all the lateral edges are congruent. That means AE, this segment, is congruent to DH, and DH is congruent to CG, and CG is congruent to BF. Okay, by the property of a prism, all the lateral edges are congruent. So we apply, or we substitute this thing. So let's write it here. AE is equal to DH. This is the same as CG and BF. Okay, say all these are some constant K. So we apply definition of rectangle in all these cases. So this rectangle, the area of this rectangle is AE times AE times EH. Okay, so this is AE times EH. Okay, the area of this front part is this part times this part. Okay, so you have to write it like this, plus the area of DHGC. DHGC, the area of this rectangle is the product of DH times HG. Okay, say DH times HG plus the area of the back part. Okay, the area of BCGH is BC times CG. Okay, BC times CG plus the area of the other side, the area of rectangle ABFE is AB times BF, or you can make it AB times AE, the same thing. So this is AE times AB times BF. Okay, so now we substitute in all the lateral edges, we substitute a certain constant K. So in place of AE, you can replace K. So this is the same as K times EH plus here DH times HG. Okay, DH is constant. Okay, so DH is constant. So in place of DH, you can substitute K times HG plus the area of the back part, BC times CG. BC times CG, and CG is K. So you can write it K times BC. Okay, the order doesn't matter. Multiplication is commutative. Okay, in place of CG, you can substitute K. You can write BC as it is, so it becomes K times BC. Okay, the last one is AB times BF. AB times BF, but BF is constant K. So this is K times AB. Okay, so here in all these terms, we have a constant K, so you can factor out the constant K, and it becomes K times EH plus HG plus BC plus AB. Okay, now I need you to consider what this sum looks like. EH, HG, BC, AB. Okay, EH, HG, here, EH, we have this EH, HG, we have this side, plus BC, which is this one. By the way, in the property, we said that the base edges are parallel and congruent, so BC is exactly the same as FG. Okay, so you can consider this BC as FG. Okay, so we do have this thing. And the last one is AB, this AB. AB is the same as EF. So in place of AB, you can also replace EF. Okay, so by the properties of a prism, the base edges are parallel and congruent. So now, what is the sum of all these sides in the base? Okay, for any rectangle, the sum of the sides is called perimeter. Okay, so in place of this summation, you can substitute P, K times P. Okay, so AL becomes K times P, where this K is the lateral edge. Okay, so whenever you have any prism, whether it is rectangular prism or triangular prism, whatever, the lateral surface area of any prism is the product of the perimeter of the base times the edge. Okay, the lateral edge. Okay, so this is the formula that we use to calculate the lateral surface area. So if we have this, now what is the total surface area of a prism? As I have said earlier, the total surface area of a prism refers to the area of each faces together with the upper base and lower base. Okay, so since the upper base and the lower bases are congruent for any prism, you can take one of the base and multiply by 2. Therefore, the total surface area of any prism is calculated by the formula AL plus 2 times area of the base. Okay, this is the formula that we use to calculate the total surface area of any prism. And the third formula that we have here is the volume of a prism. Okay, when I write VP, I mean to say that volume of a prism. Okay, so the volume of a prism is calculated by the formula area of the base times height. Okay, you can calculate the base area and multiply by height. That gives the volume of a prism. Okay, so you need to take these three formulas. Okay, you need to remember these three formulas. Then based on this formula, we will try to see some examples on measurements. Okay? Okay, now let's see the first example on a prism. Okay, in this first example, we will try to see how we can calculate the lateral surface area and the lateral surface area, the total surface area, and the volume of a prism. Okay, so here, find the lateral total surface area and the volume of the prism given here. Okay, as you can see here, clearly this is a prism with a rectangular base, so that you can call it a rectangular prism. Okay, in this figure, we are asked to calculate the lateral surface area, the total surface area, and the volume of this prism. So we will apply the formula that we have seen before. Okay, so the lateral surface area denoted by AL is given by the perimeter of the base times the height L, or you can call it K, whatever variable, but that represents the lateral edge. Okay, so this P refers to the perimeter of the base. Now, whenever you see this figure, this side is 8. Since it's a rectangular prism, the opposite sides are congruent. So if this is 8, this should be 8. Okay, if this side is 6, this side is 6. Okay, they are equivalent and parallel. Now, the perimeter of this prism is the sum of each side. So the sum of each side means we have 8 centimeter by 2, because we have 8, so you can multiply it by 2, plus 6, so totally 6 centimeter by 2. Okay, we multiply, this is a perimeter of the base. We multiply this perimeter by the lateral edge. Okay, by the way, this and this are the same. We have seen this in the property of a prism. So this can serve as a height. Therefore, the lateral edge is 5. You can multiply this by 5 centimeters. The result gives us the lateral surface area of the prism. So now let's calculate this thing. So this is 16 centimeter. 16 centimeter plus 12 centimeter times 5 centimeter. Okay, the sum of these two is 28. So whenever you multiply 28 by 5, the result is around 140. Centimeter by centimeter is centimeter square. Therefore, the lateral surface area of this prism is 140 centimeters square. Okay, so we have answered the first part of the question here. The next one is, we are also asked to calculate the total surface area of this prism. As I have said before, the total surface area of a prism is the sum of the lateral surface area and the area of the bases. So the total surface area is given by the sum of the lateral surface area plus the area of the two bases. So you can multiply one of the area by 2. Okay, we already have the first part, the lateral surface area, which is 140 centimeters square, plus 2 times the area of the base. As you can see here, the base is rectangular. You all know that the area of a rectangle is the product of length times width. So you can multiply 8 by 6. That gives you the area of the base. We do have two bases, so we have to multiply it by 2. So 2 times 8 centimeter times 6 centimeter. Okay, this product is 48 centimeter square. Okay, 8 times 6 is 48. Centimeter by centimeter is centimeter square. 48 by 2 is 96. Okay, so we add 140 centimeter square with 96 centimeter square. So totally this is 236 centimeter square. I think the sum of these two is 236 centimeter square, which is the total surface area of the prism. Okay? And lastly, we are also asked to calculate the volume of this prism. So the volume of a prism, shortly you can write it VP to represent volume of a prism. Okay, so the volume of a prism is calculated by the formula area of the base times the height. Okay, area of the base times height. Okay, you can take only one of the base, calculate the area, and multiply by height. Okay, so the area of the base is 8 centimeter, okay, 8 centimeter by 6 centimeter. And the height of this prism is this one, or this one. You can take one of the each. So 5 centimeter is the height. Okay, so now the product of all these three gives us the volume of a prism. It's around 48 times 5, which is around 240. I think it's around 240, okay, 240 centimeter cube. Okay, you can check if this is wrong, but I think the product of these three numbers is 240 centimeter, centimeter, centimeter. The product of these three units is centimeter cube. So the volume of this prism is 240 centimeter cube. This is how you need to calculate the measurements associated with a prism. Okay, now let's see another example regarding a prism. Okay, now let's see the second example. In the second example, we are asked to find the lateral surface area of a triangular prism. Okay, so just to recall what triangular prism is, a triangular prism is a prism whose bases are triangular. Okay, roughly it looks like this one. Okay, so this is a triangular prism. Okay, and this triangular prism, what is given, the height of this triangular prism is given, which is 10 centimeter. The other thing is the dimensions of the bases are given, 4, 5, 6. Okay, you can say this is 4 centimeter, this is 5 centimeter, and this is 6 centimeter. Okay, so based on this information, we are asked to calculate the lateral surface area of the given prism. Okay, so the only thing that you need to know here is the formula for a lateral surface area. Okay, so we said that the lateral surface area is the product of perimeter of the base times height. Okay, so the perimeter of a base is the sum of all the sides. Okay, so the sum is 4 centimeter plus 5 centimeter plus 6 centimeter. We multiply this perimeter by height, and our height is 10 centimeter. Okay, so the sum of these three numbers is 15 centimeter. We multiply it by 10 centimeter. So this product gives us 150 centimeter square. Okay, so this is how you calculate the area of a prism, particularly the lateral surface area of a prism. Maybe if you are asked to answer the total surface area of this prism, the only thing that you can do is you need to calculate the area of the base, one of the area of the base, and multiply it by 2. Then that result should be added with the lateral surface area that gives the total surface area of a prism. Whenever we are asked the volume, we calculate the area of the base. After you obtain the area of a base, you multiply it by the height that gives the volume of a prism. Okay, so these are the point of discussion for today. Just in this lesson, we have seen what a prism looks like. We have seen different types of prism and their properties. Then after we